Welcome, everyone, to the deep dive. Today, we're looking at some pretty surprising source material. It connects two things I never thought I'd say together: calculus and drying spices, like paprika.
Seriously. It sounds odd, but yeah, our mission here, looking at these sources, is to really unpack how a core calculus concept isn't just, abstract math on a blackboard. It's actually a tool, a pretty powerful one used in this really tangible kind of everyday scenario. And hey, if you happen to be wrestling with calculus in college right now, this is definitely for you.
I have to say, when I first saw this, I was stumped. Calculus, for me, that's like graphs, areas under curves, maybe rates of change, and then spices drying. In the sun, where does the math
Yeah.
even come in? I mean, couldn't you just weigh the spices before and after they dry?
But that's where it gets really interesting, and the sources we're looking at explain it quite well. This deep dive, it focuses specifically on using integration.
Okay, integration, right after differentiation, usually. Finding the total.
Exactly. That idea of accumulation, of adding up change.
Yeah.
But not just for, like, finding the area under some theoretical curve. Here, it's used to measure something super practical in agriculture.
Yeah.
The exact amount of water that evaporates, that's lost, when you dry spices using the sun.
Okay, right, there it is. That's the connection I was missing. So it's not just saying, yeah, some water left. It's about quantifying the moisture that escapes the spice itself. So why integration? Why is that the specific math tool needed here? Not just, well, subtraction.
Well, think about it. Water leaving a spice as it dries.
Hmm.
Not like flipping a switch.
Right.
It doesn't happen all at once.
Yeah.
It's a continuous process. It happens gradually over hours, maybe days.
Right. Slowly evaporating.
And the rate at which that water leaves is not constant. The sources talk about this. It changes. Depends on the sun's heat, the air humidity, even how much your surface area is exposed.
Ah, okay. Hotter means faster, maybe.
Probably, yeah. So you might measure the rate of water loss at different moments. Integration, well, that's precisely the mathematical tool designed to add up, to find the total accumulation of something that's changing continuously over a period.
So you could measure, say, how many grams of water are evaporating per hour at noon.
Uh-huh.
And maybe it's fewer grams per hour later in the afternoon when it cools down.
Exactly.
And integration lets you sum up all those changing rates over the entire drying time to get the final total water loss.
You've got it. You integrate the rate of loss over the time interval. The sources point out why this precision is actually vital. It's not just academic. Knowing that exact water content, it affects everything. Shelf life, stopping mold growth, keeping the flavor and color right. It helps farmers figure out the best, most efficient drying times.
Wow. Okay, so it's genuinely practical. It moves it from just leaving stuff in the sun, hoping for the best.
To a scientifically managed process. Quality control in the spice industry, basically. Knowing precisely when it's perfectly dried, not too much, not too little.
That really does make the math feel, well, real, tangible.
It shows the value, doesn't it? Calculus and integration specifically gives us these incredibly solid tools for measuring and understanding things that change over time. And in fields, you might, never connect with advanced math. It turns guesswork into science.
Definitely. So if you are that student, like staring at integral signs right now, maybe think about this time you're cooking. It's not just abstract curves. It could be about the moisture in the paprika in your hand.
Right. Calculus isn't just locked away in textbooks. It's out there, helping us understand and quantify the real world, making things work better.
It really makes you think, doesn't it? What other everyday things, maybe, I don't know, baking bread and how it rises, or even just watering plants in the garden, could there be mathematical principles, maybe ones you're learning right now, quietly describing those processes too?
That's a great question to ponder.
Definitely something to think about. Okay, that wraps up our deep dive for today. Thanks for joining us.